So I've got my PCB manufactured. I got it manufactured out in JLC PCB out in Shenzhen. I went for them for a couple of reasons. I'm not affiliated with them in any way, but they can offer it in matte black, which I think looks really good. Also, I've heard good reviews from them, and they've got a really fast turnaround, and it was cheap. 5 of these boards cost me £25, and that's including the stencil, which is, I think, very, very cheap, considering the size of them as well. And it was with me within a week. The board itself has come out really well. I really like the rounded corners and everything that I've put in. Those have turned out really nicely. The logo as well, that's come out real nice. Most of the components fit. I've dried fitted all the components, they're okay. The one mistake, or the mistake I've made with the footprint, is the optocouplers, the bigger optocouplers. They're slightly off. It's manageable, I can work around with that, and I think if I were to make this board in the future, maybe if anyone else wanted to buy a board as such, I'll be changing those slow optocouplers for much faster optocouplers, so those would be gone. There's a couple of other problems I've actually found out as well, which I'll probably change in my future revisions. But the reason why everything's so spaced out, or seems so spaced out, and you probably can't see, but everything is in its own isolation ground plane. So it's a breakout board, that's its purpose. But let's see if I can get it on the camera. But you can just about make out that you can follow this line all the way through, and each area is its own ground plane, but the clearance between the ground planes is not very big, so I do need to increase that clearance, and I think that will probably increase its isolation resistance or isolation voltage between the two. There's also a couple of problems with the footprint with the relays. The holes are just too big, so minor problems, nothing major. And then the vias, so the vias on the MOSFETs, what I need to do is I need to move these vias outside. I'm not sure why I put them in there in the first place. There's enough room outside, but they're quite close to the drain source and gate, so I think I'm going to go ahead and change that. Otherwise, the board itself has turned out really well. I'm really happy with it. It looks good. It looks real good, and I think it's going to look real good in the cabinet. I've actually tried it out in the cabinet just to see what it looks like, see if it fits, and it does, so happy days there. I've actually also tried soldering some stuff onto here, so I'm using Reflow. I'm going to try to video that for you in a bit, but you can see that things are soldering just fine. Just a couple of resistors that I've put on so far, so they're looking good. Yeah, all in all, I'm happy. Hopefully the thing works. We'll find out soon.
So I'm cleaning off the board with some acetone, standard procedure. And then after this, what I'm going to do is I'm going to actually use a top board to stop my board from moving forward, and then I've got some, they're like DIY spacers, 1mm DIY spacers, and I'm just going to mask them down on the actual glass plate. So I'm using a glass plate. The idea is it's flatter than the crappy table I've got, but in actual reality the boards are slightly warped, so it doesn't really help that much. But it's better than using the crappy table anyway. So do this, we'll put the masking tape on, and then we're going to put the stencil on top of this. And then this setup actually works quite well, so I'd go ahead and I wouldn't really change it if I were to do it again. So just using some solder paste here, and then I'm using the stencil, and then effectively standard procedure, put some solder paste on, use a credit card, smear it over. The solder paste itself is some cheap stuff off eBay. It's I think it's 63% tin, 37% lead, don't hold me to that, might be the other way around. But yeah, it's got some flux in it, works quite well, it's cheap. I bought 2 tubs, I only needed 1, so I didn't use half of the one that I actually bought, so I'd go ahead and only buy 1 if I was doing a similar sized board again. I'm using a credit card to smear over the solder paste. My first attempt, I did this quite a lot, I just kept on smearing it on quite a while, and that's what I filmed over here, but actually I had to do this again, and I didn't spend so long with a credit card. It doesn't need that much, it doesn't need to be rubbed in as such, just a quick smear over it is more than enough. So I'm onto your component placement over here. So most of my components, or most of my resistors, capacitors and whatnot are 0603. They're okay, they look really small, but actually they're quite manageable. I think the biggest problem over here is just not getting your hand smearing over the solder paste across the board. Fortunately that didn't happen to me, but yeah. The components themselves took me about 3 hours, maybe 4 hours to put all the components down. I think I had in the region of about maybe 400 components to put down, but actually it wasn't that bad. It was okay. I mean, the LEDs were probably the most painful one because you need to make sure they're like aligned correctly and in the right orientation. So I've opted to go for a local reflow here, mainly because I don't have a reflow oven. I don't know anyone that does, and there's no point me making one just for this board. The local reflow seems to work really well. It's quite nice. It's almost magical watching the solder paste reflow into paste, and it's also magical seeing the back of my head because I can't get better shots of this. I think you need better lenses. My camera equipment is pretty poor. So you're going to have to watch other YouTube videos to watch that magic happen. But in this instance, just a standard heat gun or a standard solder and reflow gun going ahead locally. It may well put some stresses here and there into the components, and I may find problems later on in the future, but the end result was pretty good. Everything seemed to stick well. I only had maybe 1 or 2 areas where in which the reflow didn't really work and had to go over with the actual soldering iron. So what I'm doing over here is I'm using the header pins on the motion controller and I'm slotting them in place, and then I'm using that to guide that onto the actual breakout board. So this has actually worked out quite well, and the actual controller itself fits quite nicely. I'm using some flux, which you're going to see in a bit. The flux is just from Farnell. It's in a flux pen, but it's really great stuff. It's just an absolute pain to get off the board later on. So I'm using these DB25 pin headers, but I think they're the wrong headers. So I think if you're going to solder something like this onto a PCB board, you should get the PCB board mounted ones. And I've also put in the hex nut, or the nut the connector actually screws into, on the PCB board itself, but that should be on the header, so it's a bit stupid, but it just means I need to use longer screws on the actual connector itself. But yeah, if I was doing this again, I'd probably get the right headers. It doesn't actually cause me any problems later on, it just looks a bit better. So I'm using these Omron relays. They're like see-through relays, and I think they look really good. They look really nice mounted in the cabinet later on, which I'll show you in some future videos. But I've just put the holes on the breakout board slightly too large for them, but to be honest, it's not really a big issue, it's not a problem. In the future, I think if I was making these boards again, I'd probably increase the clearance between the tracks, because I think at the moment it's not rated for running anything higher than 24 volts, which is a bit of a bummer because I'm using a 240 volt contactor on the actual enclosure itself, so having that rating would probably be beneficial for myself. So I'll probably look to increase those clearance, and then hopefully they'll be able to be used for higher voltages. I've actually placed the relays quite close to the edge of the board because of that reason, but hey ho, something needs to be fixed in the future. So I'm using some isopropanol with just an old toothbrush, probably my brother's toothbrush, but he doesn't know about it yet. But yeah, anyway, I'm getting rid of the excess flux on the board, so if you don't get rid of the flux, it's just going to corrode your joints over time, because that's what flux normally does, it itches away at your copper surfaces. It's an absolute pain to get off, but eventually it does get off and it cleans up really nicely. So the board starts to look really nice after this.
So I finished soldering up components. I'm really happy with the way everything's turned out, especially the soldering. I haven't ever used a stencil before, but the chips and everything have come out really well. The component placement's really good as well. Hardly any components are offline, so I'm pretty happy with it. It also looks pretty good. I think it looks really stunning. The see-through relays, they really add another dimension to the board. They look really nice. And also, I'm quite liking the array of MOSFETs at the bottom over here. Obviously there were some problems. I always knew there was going to be problems here and there, but some of them were really frustrating. For example, that slow optocoupler right there. That one there, well, I was testing it, wasn't getting anything out of it. Put my multimeter across here, measured the amperage, the forward voltage drop across the diode and everything, and that was absolutely fine, exactly as I predicted. But the problem is, that thing there was faulty, so I changed it again, measured everything again, and exactly the same. Everything wasn't working, so I was like, wonder what's going on here. Surely two components can't be faulty. But no, I think that component there was faulty because I changed it once again, so that's my third component there, and now it's working. I do have a problem with one of my wires that run through. I'm not sure if that's a problem that I've caused, but one of these is actually not connected to the right pin. I think I might just manually solder that across because for whatever reason that's not connected. But that's not a biggie, it's not part of my main safety system or anything, so I can actually work around that and work with that. But yeah, that's probably something with the board. I measured the other boards as well and they're actually fine, so maybe it's something in particular with this one. The actual components themselves have gone in well, but apart from this over here, so in a couple of instances on Eagle I never connected the grounds up, and this was a problem because the optocouplers were never connected to ground, so I've had to modify the board there. And I've also happened to done the same thing on one of the wires. So the wires over here, you can see I've just shorted them to ground simply because they're supposed to be connected to ground, but they're not. So yeah, otherwise everything works really well. I've actually tested the board. I've only tested it with some dumb IOs here and there, and everything seems to work fine. I'll show you in a second. The actual controller itself, so that fits really nicely over here. That just slots into place. I'm not going to fully put that in place now because it's an absolute bummer to get off, but it fits in real well. Yeah, so it's just absolutely flush with the base of the actual board itself, so I'm really happy with that.